Hello guys and welcome back to our computer networks course. So in this lecture, we will finally be beginning with congestion control, right? We've been discussing this for so long, our tap, pipe and bucket example. We always skipped over the pipe part, right? So this is when we finally discuss the pipe. So let's get right into it and discuss how our congestion control works. All right, so let's begin with our example, right? So you have a tap and this was your sender. You have a pipe and this is your network, right? And then you had a bucket and that was your receiver, right? So we have been skipping over stuff, right? We have been saying that we will talk about this later, but we never really talked about it. So this is the time when we talk about it, right? So I said that you cannot send more than you can send, right? That is obvious, right? This opening has a certain diameter, right? And that defines what the maximum amount that it can send is, right? So it can obviously not send more than that, right? But it can send more than this guy's diameter can accept at any given point, right? So matlab, if this guy cannot accept that much water at that point, what's going to happen is it's going to spill over, right? It's going to spill over. So we do not want that to happen. So that was your matlab, this is your sender window, okay? Sender window. This is your receiver window, okay? However, this guy also has a window, right? Well, you cannot send more than this guy can carry, right? If you send more than this, you might notice some holes leaking waters, right? You might notice some holes that would be leaking waters, or it would completely have a backflow, okay? So water would be spilling everywhere, okay? So this guy also has a capacity, and that capacity is your congestion window, right? So CWND, congestion window, okay? So your network also has a capacity and that is your congestion window. That is the maximum that it can handle at any given point, okay? So what I'm saying is the amount that you should send, let's use a different color. The amount that you should send should be the smaller one out of your receiving window and your congestion window, right? So whichever is smaller, right? Of course. So if I can send 5, my network can handle 3, but my receiver can only receive 2. I should be sending 2, right? Because what's the point of sending more? If I send, let's say I send 3, so my network can handle it, but this guy cannot, right? So 1 gets wasted. No point sending more than that, right? What if I were to send 5? My network cannot handle it. Okay, so 3 would be accepted, 2 are discarded right here, and then 1 gets discarded right here, right? So 3 are discarded anyways, है ना? So what is accepted is only 2. Okay, so no matter what you do, you will only be able to accept whatever is the minimum of things, right? So let's reverse the situation and see that that is also true for the reverse case, right? So our network can handle 2, but my receiver can handle 3, right? So what happens if I try to send 3 now? I send 3, my network cannot handle 3. 1 gets lost. 2 gets forwarded, right? Even though this guy can accept 3, he can only receive 2, right? Because the network cannot transfer that information, right? So only 2 would be accepted, right? So whichever is the minimum, right? Whichever is the minimum, this is your C window, right? Congestion window, and this is your receiver window, okay? So whichever is the minimum out of these two is the one that we would be selecting, right? So we can say simply that our window is equal to minimum of congestion window and receiver window, okay? Hopefully that was very clear in how our pipe, bucket and tap example connects with our congestion, right? Congestion is basically excess of stuff in your channel, right? So the difference between congestion and your flow, right? The difference between congestion and your flow is that congestion is in your channel, right? It's in your channel, it's in your network, right? But flow basically concerns your receiver and your sender. It does not care about what happens in between. Okay? It only cares about the endpoint and the beginning point. It does not care what happens in between. Congestion control does not care about what happens in the beginning, what happens in the end. It cares about the channel. Okay? All right. So let's talk about our how congestion can be controlled, right? So the way to do this is obviously this, right? We obviously change the congestion window, change the congestion window to optimize stuff, right? And the way to do that the way to do that is by using three phases, right? And those three phases are your slow start phase, congestion avoidance phase, and your congestion detection phase, right? So let's go through them one by one, and then we will discuss how these actually help, right? Then we will discuss how these actually work. So what is your slow start phase, right? So in your slow start phase, you say, matlab, we are varying our congestion window, right? We do not know what the limit of my network is, right? We do not know that. So we are going to experiment with it, and we're going to find out at every given point how much my network can actually handle, right? So I say start with one. Okay, start with the smallest guy. Okay, start with the smallest guy, and every time you are successful, increase it exponentially, right? So at my whenever this is done using your acknowledgement, right? So when I'm sending my first thing, how many acknowledgements do I have? 0. And my window size is 2 raised to power 0. Okay. Then I do set my, this is 1, right? So I set my congestion window to 1 and I would send. Okay. So receiver window, let's say, is X. So minimum, it is of course not 0, right? Let's assume that it is not 0. So 1 and X, you get the minimum. Okay. So you send it. Now you send it, you would receive an acknowledgement if it is delivered successfully. So if it is accepted successfully, you are getting an acknowledgement, and you are saying that number of acknowledgements are now 1, right? 2 raised to power 1. So now I say my congestion window is 2. Then I use this guy, and then I send again, right? So I receive another acknowledgement, and I say now my congestion window, now I have received 2 acknowledgements. So my congestion window is 2 raised to power 2. Okay. Then again. Okay. So I have a threshold. Okay. I have a threshold, and that is where we would stop doing this. So let's see. So what I said was, in our slow start, we said step 1 is congestion window equal to 1, and step 2 was congestion window is equals to 2 raised to power the number of acknowledgements I have. Okay. 2 raised to power the number of acknowledgements I have. Alright. So we do this till the time we do not reach our threshold, right? So we already have a threshold. We have this information with us. Whenever our threshold is smaller than a window, and whenever we have not crossed our threshold, we will be exponentially increasing it, right? We would be increasing it exponentially. Once we cross this guy, once our threshold becomes less than my window, let me do this. So whenever my threshold becomes less than or equal to my window, I move on to my next stage. Okay, I will move on to my next stage, and that is your congestion avoidance, right? This simply says that this was slow start, right? We are slowly reaching the most optimal congestion window, right? We are slowly incrementing to the, not slowly, we start slowly, but then we try to reach the optimal position very fast, right? So we reach a threshold, and then we say, okay, let's move on to our congestion avoidance phase, right? And that says that my congestion has not occurred yet, but we are already past our threshold, right? So it might occur at any given point. So let's do one thing, and let's not increase load exponentially, right? Let's still increase it because we are still not at the optimal position, but now let's not do it exponentially, right? Let's do it linearly. So what we do is, now every acknowledgement I get, what I'm going to do is, I am going to say my current window plus 1. Okay, my current window plus 1. Okay. So what that says is, whenever you receive your acknowledgement, whenever you have a success, increase your window, but don't do it exponentially, do it linearly. Instead of multiplying it by 2, instead of exponentially raising it to an exponent, you do what? You increase it by 1. Okay. So you would be doing what? You would be doing C window increment, right? That is what we are doing. And you do this till when? till the time you detect congestion, right? Till the time you detect congestion, you do this. Okay. So basically you keep doing this on every act, है ना? So मतलब on acknowledgement, right? As soon as you receive an acknowledgement, you increment my window. Okay, you make it bigger, make it bigger, make it bigger. Okay. Then there are two ways that I can detect congestion, right? There are two ways that I can detect congestion, and we have discussed both of them before this, right? We have discussed both of them before this, and the first method is timeout. Okay, the first method is timeout, and the second method is my 3 duplicate acts. Okay, so my second method is 3 duplicate acts. Oh, so whenever one of these two things happen, what would I do? What would I do is whatever my current window is, and wherever my current window is, I would say half of this is my threshold. Okay, half of this is my threshold. So let me show you. Let's use our graph now because we have enough information now. So let's use this and see. So right. So we start in a slow start phase. Okay, we start in a slow start phase. We said that our window is initially 1, but you exponent it every time, right? So 2 raised to power 1 becomes 2, 2 raised to power 2 becomes 4, right? 2 raised to power 3 becomes 8. Okay, 2 raised to power 4 becomes 16. Now I have reached my threshold. I have reached my threshold. So once I reach my threshold, I say every successful, I will only increment it, है ना? So on 5 it would become 17. ठीक है? On 6 it would become 18. On 7 it would become 19. ठीक है? On 8 it becomes 20. But this guy, after becoming 20, has a timeout, right? Timeout means you send something and your timer expired for that guy, but you did not receive an acknowledgement, right? That is what your timeout is. So once your timeout happens, what you say is my threshold is half of whatever my current window size is, right? So my current window size is 20. It is 20. So I say my new threshold is what? 10. Okay. My new threshold is 10, and I will now again start from slow start. Okay. So let's move back and let's see what we talked about. Okay. So now we are saying once you detect congestion, you do what? You set a current threshold. You set threshold equal to half of current window. Okay. Then you do what? You set current window equal to 1 and you begin with what? Slow start. Okay. You begin with your slow start phase. You set your threshold to half of current window and then you move to your slow start phase. I am stressing on this point a lot because you are setting threshold to the half of your current window, right? So let's move back to our diagram and let's see it here, right? So I'm not setting my threshold to half. That would have been 8, right? What I'm doing is setting it to half of what my current window was when something bad happened, right? When congestion happened. Okay. So whatever my window was when congestion happened is what you half. Okay. Hopefully that was clear. Now let's see why we are saying that we are detecting congestion when there is a timeout or when there is 3 duplicate acknowledgement, right? So those were the 3 phases, right? You keep fluctuating through them and you get the most optimal congestion window eventually, right? Okay. Let's see. So let's see why your timeout or 3 duplicate stack say that you have detected congestion. Okay. So that's my sender and that's my receiver. All right. So this guy sends something. Okay. I start a timer. Now I send something else. Okay. What happened was this guy's timer expired. and I did not receive an acknowledgement for this guy. ठीक है, I did not receive an acknowledgement. That means what happened? Timeout happened. And we are saying one possible cause of this guy being lost is what? Congestion, right? Because if there is congestion, the nodes in between would be dropping some stuff to make sure that it is not too much letters, to make sure that it can actually handle stuff, right? So it is going to discard some stuff, right? So we are saying one possible cause of this guy we not receiving an acknowledgement before my timeout actually happens is congestion, right? So that is how I am saying that there is a possibility of congestion happening if a timeout happens. And that is why we say that whenever a timeout is happened, we are in congestion, right? So we move to our congestion detection phase. Okay. So that was for your timeout bit. Let's talk about your 3 duplicate acknowledgements, right? And how that could possibly be an indication of congestion. Okay. So I sent something and my timer is here. Okay. And I received an acknowledgement for it. Now I sent something else, a second thing, but what I received was my acknowledgement for the previous guy. So I said maybe that has not reached you, it will reach eventually. So I sent him another thing. But what I receive in exchange is the acknowledgement for the first guy. I say maybe it has still not reached you, maybe it would reach really soon. Okay. But again, what I get in return is acknowledgement for the first guy. So basically what he's saying is I have not received the second guy yet. Okay, that is what it is saying. Okay, that is what it is saying, that I have not received the second guy yet. So you keep sending me more stuff, but I have not received this guy. So there's no point in you doing that, right? This is your 3 duplicate acknowledgements, right? Your 3 duplicate acknowledgements. And that, see, the thing is your timer has not yet expired, right? So timer would expire somewhere here. Okay. But I have already received 3 duplicate acknowledgements, and that is an indication that this guy has been lost. Okay. Again, we are saying that since something is lost, this is an indication of congestion, right? One plausible reason why this would get lost is congestion. Okay. So then again, we move on to our congestion detection phase, right? Because we are saying that if this has happened, if you have received 3 duplicate acknowledgement, it means that you have lost something, and the possible cause of that losing something is your congestion, right? So we would move on to our congestion detection phase. Okay. So hopefully that made it fairly clear to why we are saying that timeout and 3 duplicate tags are the condition detection parts, right? Why we are moving on these conditions to our condition detection. Okay. All right. So hopefully you now understand congestion control completely, right? So we start with a very small window, right? And we keep on increasing it exponentially till the time we reach an optimal situation, right? And then we say there is a possible chance, once we cross a threshold, we say that there is no sign of congestion yet, but there is a possible chance of congestion, right? Because we have already crossed the threshold. So let's do one thing, let's keep increasing, but let's not increase it by that much, right? Let's not increase it by that much. Let's only increase it very, very slowly. Okay. So now what we would do is we would still be increasing it, but we would be increasing it simply by 1. Okay. Instead of exponentially increasing it, instead of saying 2 raised to the power of acknowledgements, we are saying it is plus the number of acknowledgements. Okay. So that is how we are increasing. And then we say that we have detected a timeout. We have detected a 3 duplicate acknowledgements, right? And that says that there is a fair chance that we have encountered congestion. So what we should do is we should take even more precautions, and we should shorten our congestion window, right? We should shorten our congestion window so that we can make sure that if there is congestion, we do not lose too much over it, right? So for this all to make sense, you must always remember that your current window, okay, your sender window, not current window, your sender window is equal to minimum of receiver window and congestion window. Okay. To make sense of this, again, remember our tap example. Not more than what your pipe can carry, not more than what your bucket can receive. All right, let's meet in the next lecture.